Good morning, friends. I hope everyone is doing well. I request everyone to watch my videos in a sequence for better understanding. In the previous videos, I have discussed what is a structural hazard. In this video, I want to discuss the solution for avoiding the structural hazard, which is resource duplication. Are you able to understand? We have to duplicate the resource. What is a structural hazard? If you have a very limited number of resources, in a computer we have limited resources such as registers, ALU, cache memory, main memory. However, we will execute n number of instructions at a time. So we have large number of instructions and we have very few resources. Then what will happen? At any point, more than one instruction can try to access for a particular resource. Then we will have a problem. So let me discuss what is the structural hazard with a simple example. Then we will go for the solution for it. Okay. Let me discuss what is a structural hazard. Suppose let's take that I am performing instruction fetch, instruction decode, operand fetch, execute operation and write back in a pipeline. So if I want to instruct or execute an instruction, I have to perform instruction fetch, instruction decode, operand fetch, execute, write back. I am taking a 5-stage pipeline. Okay. In the clock cycle 1, instruction fetch will be happen. In clock cycle 2, instruction decode will happen. In clock cycle 3, operand fetch. 4 and 5, you will perform execute and write back. It is write back. Sorry for it. It is write back. Similarly, instruction 1 will perform its fetch in clock cycle 2. Decode you will do, operand fetch you will do, you will perform execute and write back in the clock cycle 6. Okay, in the clock cycle 6 you will do it. Similarly, instruction 2 will perform its instruction fetch, instruction decode, you will perform operand fetch, you will perform execution, you will do the write back. Is it clear? Similarly, instruction 3 will perform fetch, decode, operand fetch, execute and write back. Okay, because I need to bring the resource conflict, so that's why I'm writing these many instructions. I know that you understand how to execute the instructions in pipeline. Okay. Is it clear? Are you able to understand? Now if you see this one, what you are doing in instruction I0 at the 5th clock cycle, you are performing the write back option. Am I right? Similarly, I4, you are doing the same at the 5th clock cycle, you are performing the instruction fetch. From where you will fetch the instruction? You will fetch the instruction from the memory. Let's take that you are fetching the instructions from the memory. Then from where you will fetch the instruction? You will fetch the instruction from the main memory. Then similarly, where you will perform the write back option? If the operands are there in the main memory, then you will perform the write back operation in the main memory. So at the clock cycle 5, instruction I0 and instruction I4 is accessing the resource called main memory. So you can see this example. At the same time, more than one instruction is trying to access the same resource. Is it possible? Can we do it? We cannot do it. So then what we should do? The solution is that your best simple solution. Okay, you don't perform anything. You make it as a stall cycle and start performing the fetch from here. But what is the problem with this one? If you introduce the stall cycles or if you increase the number of stall cycles in the pipeline, the performance of the pipeline architecture will degrade. Is it clear? What is the use of the pipeline? If I have n number of instructions, or here if I have 4 number of instructions, I have to use or execute these 4 instructions in less number of cycles. That is what the pipeline concept. if I increase if I introduce the more number of stall cycles, then the number of clock cycles will increase. If the number of clock cycles will increase, the performance of the pipeline architecture will degrade. What is an objective of any pipeline architecture? The clocks per instruction or cycles per instruction should be almost equal to 1. If I introduce the stall cycles, I cannot achieve this objective. Then what should I do? I should go for the resource duplication. However, it is a costly process, but how we will do is that we will divide the memory into two parts, consists of instructions and we have for the data. Are you able to understand? We will do the resource duplication such as we will have a memory, we will divide into two parts, such as in one part we will save all the instructions and in another part we will save all the data. Are you able to understand? Suppose let's take that instruction I0. I am storing here. Instruction I4 I am storing here. Okay. Now the write back option, where it will happen on the data, meaning is that if instruction I0 is having some operand A and B, so on A and B will be there at the data location. Am I right or wrong? So there you are performing the right option. And similarly instruction 4 is doing on C and D. Now let's see that in clock cycle 5, I0 what it is doing, it is performing the write back option. So where it will do, it will perform its operations on the data. Am I right or wrong? Whereas I4 is fetching the instructions. So where it will perform the operation, it will try to fetch the instruction from the instruction part. So now both are doing at different locations. So there is no problem. Are you able to understand? However, it is a costly process. Or let's take that with another example. Suppose they are accessing from the cache memory. Then I will make it as one instruction cache. I will make the cache into two subparts. One is consists of instruction cache, which consists of only instructions. And I will have a data cache, which will consist of only data. So this concept we will call it as a resource duplication. Okay. So if you do the resource duplication, we can try to reduce the structural hazards. We cannot eliminate them. Are you able to understand? Somewhere else we will get it, but still, however, we will try to reduce the structural hazards. I hope you have understood what is a structural hazard, why the structural hazard problem will come, and how we will eliminate the structural hazard. I hope you have understood all the concept. If you still have any doubts related to this concept, feel free to ask me in the comment section. I will try to clear your doubts in less than 24 hours. Thank you for watching my video. Have a nice day.